A good day to Dr. Sajahan, Ms. Norazwa, and also Mr. Husband. Thank you very much for taking your time in watching and evaluating my presentation over here. My name is Tiibban Ganthan and my matrix number is B0517102213. And my supervisor over here is Dr. Saifudin. My title of my final year project would be UTeM Lake Smart Water Quality Sampling using IoT application. At first will be the problem statement. After doing multiple research on this topic over here, I've came out with multiple problem statements. And the first one and the main one is a lot of time and tools, expensive tools are needed in order to calculate the DO or the dissolved oxygen value of water. Dissolved oxygen value of the water is very important to sustain life in ecosystems basically. So the thing is that it also needs people to be there in the middle of the site, let's say in the middle of the river or the lake in order to take this value, and this requires a lot of time, and to come up with an accurate and more efficient dissolved oxygen value you have to take it multiple times, maybe throughout the day or throughout the week itself, in order to make sure that the water quality is good. So in order to people to go in the middle of the lake and also middle of the river, it takes a lot of time and effort. And after that we come to the objectives of this project. There are two main objectives of this project, and the first one is to develop a water monitoring system at UTeM with the feature of Internet of Things, where I'm going to enable monitoring the dissolved oxygen and biochemical oxygen demand values from anywhere at any time of UTeM Lake. And the second one is to reduce the time taken and the effort needed to test the water, because from what I've learned, it takes a lot of time and effort to determine the dissolved oxygen value of a body of water, where you have to be present in the site, and it takes a lot of time and effort to calculate and also determine the dissolved oxygen value of a body of water. And now we go to our scope. My first scope would be dissolved oxygen. Dissolved oxygen determines the quality of water for life to live, and in example, fishes and other aquatic lives. Dissolved oxygen value is also essential for aquatic lives. And other than that, it will be Internet of Things. Internet of Things allows any sensor or any other physical technologies to be observed and also sometimes to be altered via the internet at any time and any place, with the connection of internet being present. Now we move on to my methodology. On the side over here, we have my main flowchart of this whole project. And during the start, I first discussed on the type of parameters of water quality that's needed. And in this case, I have chosen dissolved oxygen value and also biochemical oxygen demand value. And after that, I chose the type of sensor that I needed. And in this case, I have chosen the dissolved oxygen probe by Atlas Scientific, which allows Arduino to be used. And in this case, I have used the Node MCU microcontroller. And after that, I go to the choose of the type of microcomputer to be used, where I have just explained that I use the Node MCU ESP8266. But at first, I was deciding on using Raspberry Pi, but then I'm not that fond of Python coding, so I've used Node MCU instead because it has Wi-Fi chip implanted too, so I don't have to add another ESP8266 module on it. And after that, we move on to the choosing the type of IoT based service that's supposed to be used. So at first, I was going to use ThinkSpeak, but I couldn't really run the code on ThinkSpeak, so I have stumbled upon an error, which I have then changed the service, and I was back into choosing the type of microcomputer that I have to use, and then back to choosing the type of IoT based service, which now I use Adafruit. And after that, I have to choose the app to display the data, where the application allows any user or specific users to use mobile apps to monitor the dissolved oxygen value and the biochemical oxygen demand value on their mobile phones. And after that, I go on to coding the system to connect the sensor with the IoT service, and then I move on into running the system at UTeM Lake, where I take the reading using a handheld device and also using my device, where I compare the results that I've came from, and also the time taken and the effort taken too, which are all stated in my results. And after that, I compare the effort and the time taken to obtain the data. Moving on, I'll then compile the results taken from my visit at UTeM, where I did the whole experiment with my device and the HANA instrument handheld device. And after that, I'll move on to my final preparation for report and also my presentation right now, which then can be handed in. And that's the end. And on my right over here, I have the conceptual diagram of my project, the basic concept of my project, where Node MCU and also dissolved oxygen probes are wired together, which is then connected through Wi-Fi, which then sends all the data that is received by the probe to Adafruit IO, where it compiles all the data and presents the data in a presentable form in gauges and in graphs. And after that, live monitoring using a web browser and phone app. And now we have the block diagram of my water quality monitoring system. And basically it starts from the node MCU ESP8266, which then goes into global system for mobile communication through Wi-Fi, which then sends all the data that is collected by the sensor, the node MCU, through Wi-Fi to Adafruit IO. So Adafruit IO then compiles and all that, compiles the data and then performs required measurements and obtain the data completely, which then stores the dissolved oxygen value in the cloud itself and also the biochemical oxygen demand value too. And now we have the flowchart of my water quality monitoring system. Is more in detail over here. So at first it starts and then initialize the Arduino Node MCU ESP8266. It then establishes Wi-Fi connection, and if the connection is successful, it then moves into the reading the sensor values. If it doesn't connect to the Wi-Fi yet, it goes back to start and it goes on a loop until it connects to the Wi-Fi. And after that, it proceeds to the read sensor values. It then reads the sensor values, and if the sensor values are available, then you'll move on to sending the data to Adafruit IO. But if it doesn't, it will then try to read back the sensor's value until it has a value to present to Adafruit IO. After sending it to Adafruit IO, then Adafruit IO will acknowledge whether the data is received or not. And if it doesn't, it will then go in a loop again, sending the data non-stop until Adafruit IO acknowledges that it has received it. And after that, we have to wait, and then the system, we can then watch and see all the data that is collected in Adafruit IO through our mobile phone and also web browser. And over here, I have my schematic diagram of my water quality monitoring system using Node MCU, of course, and also the Adler Scientific dissolved oxygen probe. And then on my right over here, I have my whole project that I have placed it in a housing. It's a waterproof housing, but it's also a waterproof junction box that I have multi-purpose into housing my project over here, because it doesn't allow any water or it doesn't weather down. And it also keeps everything together and safe inside the casing. And now I have the flowchart for my entire project that I've conducted, where I have to go to the site and also take readings using two instruments, which is my instrument, my water quality monitoring system, and also the handheld device that is sold in the market. So at start, I arrive at the project site, and in this case, is in Lake UTeM. And after that, I run the water quality test using HANA instrument first before applying my instrument itself. So using the HANA instrument, I go around the lake trying to find the location that has the lowest dissolved oxygen value, because that's the location where it determines the whole lake's dissolved oxygen value. Because if you get the lowest already, then you don't have to really worry about the highest. High is good and low is bad. And after choosing the lowest dissolved oxygen value place, and then I will run my water quality monitoring system, uh, which is then implemented in a place. And if that place has a high dissolved oxygen value, then I have to go and change the location and choosing a new location after that. After all that, I collect the data and the time taken for the dissolved oxygen value for both of the instruments, the time taken that I have to take the dissolved oxygen value using the handheld HANA instrument, and also my instrument. And after that, I analyze the data collected and compare both of the data, and then I move on to the final preparation for my presentation and also my report. And in this slide, I have shown how the data is presented in Adafruit IO. It is very user friendly and it shows the data very clearly. And in this case, I have a gauge and also a graph to look over the dissolved oxygen value and also the biochemical oxygen demand value of the lake, which is really helpful to see. And on my right, I have the data taken from the HANA instrument where I can also see the dissolved oxygen value on the HANA instrument, but then it comes to the point where I have to be at the job site to take the dissolved oxygen value and also to monitor it right there and then. And now we move into results and discussion. Over here, I've inserted the DO values that have been gotten from the HANA instrument, which is the handheld instrument, and also my water quality monitoring system. And seeing both of the values that I've gotten, the difference isn't much. I would say it's bare minimum, and the difference is somewhere between zero point 0.6 to zero point 0.4 in difference of value. In the grand scale, it isn't much. And I would say both of the devices are equally efficient in taking the values, but I would say mine is better since I wouldn't have to go into the site and take the time and effort to in order to calculate the dissolved oxygen value. My device at the same time also calculates and give a rough estimate of the biochemical oxygen demand value. F also site D, and in this case everything is highlighted in orange, which indicates poor water quality, which is somewhat polluted, but also it could sustain some lives and some aquatic lives in the case of vegetations and also small fishes. And over here would be the time taken to take reading of dissolved oxygen value of the site D. On my left over here is a handheld device which took me 10 minutes and 19 seconds from arriving at the job site and also setting up the device and also calibrating the device in the air. You have to calibrate the HANA instrument in the air first for the first 1 or 2 minutes in order to get the best values. And on my right over here, we have the my water quality monitoring system, which only took 5 seconds, which I only have to open the app to check the value. This only took me less than 5 seconds. 5 seconds is a rough estimate, by the way. I can also do that at any place at any time. From the previous slide, you can see the difference of like how much time it takes in order to get just one dissolved oxygen value using a handheld device. And you could also see the time taken to use my device in order to calculate the same dissolved oxygen value or a somewhat similar value. So now I'm going to discuss about the effort taken in order to get the dissolved oxygen value. So over here, I've placed a map. So in this case, assuming that I'm a UTeM staff coming from faculty of manufacturing. So I have to take either a car to travel all the way in order to the site, which is at the lake, which takes me 5 minutes, not considering the amount of students around, walking around for classes and all that. Or you could also walk there. Walking there, it takes me 28 minutes in order to reach the site to get the dissolved oxygen value. This shows how much effort is needed in order to go and take the dissolved oxygen value using the handheld device, where my device is always there and you can always check the dissolved oxygen value in real time at any place at any time using just your mobile app or also a web browser if you have a laptop in front of you. And now, in conclusion, the implementation of IoT to the water quality monitoring device would provide a faster and a more efficient way in order to monitor and inspect the process of water quality of our UTeM lake. And my project also successfully covers my two main objectives, and I would say my project is a success. Thank you very much.